Hi, my name is Chris. I'm a board certified behavior analyst, and I have gotten some questions about how to use my Excel template for the Standard Celeration Chart. So, this video is going to help explain that. What I'm not going to do in this video is explain what a standard acceleration chart is, all of the specific items in the chart. I'm assuming you have at least some familiarity with precision teaching and the SCC, but if you're having a little bit of trouble understanding the Excel version that I've made, that's what this video is for. And what I'll do is I'll go over the basics of this spreadsheet, and then near the end of the video, I'll go into some of the math that I'm doing. So if you're curious about the actual math and the calculations, stick to the end. So this is an overview of the standard acceleration chart. This is the classical daily count per minute with the blue lines designed by Ogden Lindsley. And this spreadsheet is actually a derivation of a spreadsheet that I found, a couple of years ago that Scott Bourne and Stuart Harder were working on. And if you've got a copy of that spreadsheet, it's great. The issue is that other spreadsheet used a lot of macros to calculate acceleration and bounce envelopes, and my company's computer software, the security software, did not play well with macros. Um, so I essentially had to build a spreadsheet from the ground up, but I was definitely taking inspiration from the way that they designed their Excel spreadsheet. So I definitely wanted to give credit to them and anybody else who worked on that Excel spreadsheet. Um, Starting off, you will find this setup page, and this setup page is the page where you're going to enter in a lot of the data that is going to format this area right here. And as you can see, I'm a big Tolkien fan, so I've just filled in a lot of the information here from some Tolkien characters. Um, the chart sync date, that does need to be a Sunday. So even if you started collecting data on Monday or Tuesday, the standard acceleration chart, it is standardized on Sundays. Um, so you do want to start the chart on whatever the nearest Sunday is to when your data actually started. And then here's some explanations here, but again, I'm going to be going over everything. The rest of these cells you can actually change. So if you don't need like division and room and charter, you can just delete those, and those areas will be deleted here. You'll get this alert because of the way the chart works. You can just ignore that. Um, the rest of this is pretty self-explanatory. You're just going to fill in all of the information that you need to. These two cells right here, these you do not want to mess with. What these cells do is these cells will tell Excel how to calculate zeros. So right now I have this set for daily count per minute, DC per M. You can change the Excel sheet to do daily count per hour, daily count per day, or weekly count per week, and it will update the way acceleration is calculated, and it will update where zeros lie on the spreadsheet. And I'll show you what that looks like here. I do have 1 0 value on the D cell, and it lands on 0.001. But the rest of these you can go ahead and change, and it won't really break anything. This cell needs to be on a Sunday, and then these two cells, really you don't want to mess with anything here. And this is very important because this is how we calculate the appropriate acceleration. The next sheet on here, you will notice that most of the sheets are locked, but if you want to edit something, you can go ahead and do it. You'll just select unprotect sheet. There is no password. This is where you're going to be entering your raw data. And what I've done is the orange cells are the cells that you're going to want to edit. I'm going to go ahead and re-protect the sheet. I generally keep the sheets protected so that I don't accidentally delete something. These hidden cells right here, You can see they're not actually hidden, but I've just made the column width very, very narrow. This is where the actual raw calculations are. So you do not want to edit any of these unless you know what you're doing. This is your raw data. Again, this is all just made up data for an example. You can put in your A cell value and your D cell value here. These are going to be the raw numbers, whether you're doing the best per trial, the total count per day, the average, whatever it is. And then here you're going to enter in your duration. And I have this set up so that you're going to enter data in hour, minute, and second format. And the reason why I did that is because when you format the time like this, it just makes it very backwards compatible. You can use the same spreadsheet to calculate things over longer periods, like over hours, over half-hour increments, over minutes, over seconds. It just makes it very, very useful for the calculations, but the problem is you do have to enter in the durations here. So you can't just enter in a 5 for 5 minutes. You would have to hit 0:05:00. But it also does allow you to enter things into seconds. And then this right here is how we calculate acceleration. Now, if you're using the Office 365 version, everything is totally automatic. You don't have to hit any buttons. If you're using the legacy version, and I am using the legacy version here, you will have to do a little bit of button presses. And what you'll do, I'm just going to go ahead and change some of these values. I'm just going to 1, 2, 3, 4, making it really, really linear here. And what you'll notice is none of these acceleration values changed. And that is because in order to make this spreadsheet compatible for older versions of Excel, I have to use pivot tables. So if you enter new data or you make a change to your data, acceleration will not work. It will not be calculated until you hit refresh all. So you're going to want to go up on the ribbon here. You're going to want to go to data and then select refresh all, and everything recalculated. And now I have a wild acceleration, which we'll see on the next sheet. I have a lot of different versions of the daily count per minute. I have a black and white one. Yeah, you can see the acceleration is wild. I have a daily count per minute black and white. And I did this just because a lot of times I'll just print it out on a black and white printer to save color ink. And when you print the blue one, the lines just really aren't all that visible, so it's just better to print in black and white. But again, if you're not going to use this, just delete these particular sheets. Daily count per minute in the blue line, a daily count per minute no line. This is actually what I'll use most of the time. You can actually just hover your mouse over the actual points and you can see the actual values here. And then I have a daily count per hour. And as you can see, the acceleration lines are not correct here because I have the chart set for daily count per minute. But I'm going to go over here, go to daily count per hour, click OK, and now acceleration is correct on here. And then I have a daily count per day. Let me zoom back out. And again, acceleration is not correct, but we're going to switch this to daily count per day. And now the acceleration lines are correct. You'll notice that the color of the actual data line got a lot thicker and changed to blue. Excel does that every once in a while. It's just annoying. So you'll have to go to Format, Unprotect Sheet, select the data line, go to Format. In the Windows version, the Format panel is over here. I'm using a Macintosh, so you'll click the Format, and and change all of this. And now it's right as rain. So a little bit of an annoying fix, but it's not the end of the world. And then I have a weekly count per week right here. And let me zoom out so I can show you this. So this is a weekly graph. And I'm going to change this to weekly count per week so that the 0 values are correct, although I don't think I have any zeros in the weeks. So this is a weekly graph, and the data for the weekly graph is actually located in this second sheet right here, weekly data. And what I have set up is Excel will actually automatically fill the first 20 weeks worth of data from the original data tab. And then after that, you're going to have to manually enter in the data. Again, I do not have any duration data here because we're summing all of the data per day and then per week in these graphs. And then what I've done, so I've got the daily count per day, I have a few equal interval line graphs here. And again, the data is really, really weird because I just made up a bunch of numbers right here. But what I've done is I've made some equal interval line graphs per minute, per hour, per day. I do have a per week in here. And they preserve the standardized nature of the standard acceleration chart. So the x-axis, the time axis, goes from 0 to 140. However, it is not a logarithmic chart. It is an equal interval line chart, obviously, and I do have the chart set up so that the maximum value is just a little bit above the actual maximum value here. So the y-axis is not standardized like in the SCC. And then I have an accuracy graph, which again, this is just a bar chart. It is standardized on the x-axis. The y-axis goes from 0% to 100%, and it's a bar chart. So black is basically the cell values. I can't talk. The Excel values. And then the white are the decel values, or rather the difference between the acell and decel values. And this would be appropriate if you're tracking something like correct versus incorrect data. So if your acell value were correct, I don't know, sight words, and your decell value were incorrect sight words or errors, this would be really, really helpful here. This right here is a data sheet. It's not locked, but the information is going to be filled in from the setup. And what you can do, as you can see in the preview right here, it'll print just on one sheet, all set up, so that if you're taking paper data, it's just this setup right here. Now, this next tab are your phases and your aim stars. And in order to, I need to know what date my data was on. So let's say that I did an intervention on 2/17/22. So 2/17/22. We'll just put intervention in the label, intervention. And then the top, I don't know, 950, and the bottom would be 0.001. That's all you have to enter. Let's go back to our daily count per minute. And the first date, the first intervention line is going to be a solid line. Acceleration disappeared. Oh, that's because it was set for the weekly count. So the first intervention line, or the first phase change line, is actually going to be set up as a phase change line. All of the other ones, so I'll just do one a few days later, and I'm lazy, so we'll just do +10, and then phase change, and then we'll do 800 and 0.01. Let's just do that, and go back to the daily count per minute. You'll see that second one is just a little bit lower. Probably should have done closer to 500. But it ended at 0.01 rather than the bottom of the chart. But you can see that it is a dashed line. And again, you can always unlock this and change this. You can reformat this to be a solid line. And of course, if you want to disconnect the lines here, you can do that in Excel, which I guess I'll show you how, just in case you're not sure. So generally speaking, in the standard acceleration chart, you have gaps for your 0 days. Um, but let's say that you wanted to have an actual break in the line between your baseline and your intervention. You can select the line, select the specific data point, go to Format. I'm going to go to the Format panel over here, and then No Line. And it now disconnected the line there. And let's see, we were talking about aim stars. I've already got some aim stars entered in. Let's see. So I think I set the aim at like 500 per minute, which is ridiculously high. Although there's some behaviors that I think you could do 500 in a minute on. But you can set successive aim stars here. Going back to this, phases and aim stars, you can set up some other ones. And you can set the A cell value and the D cell value. Don't edit any of these because it will break the spreadsheet. And that is it. That is a very bare bones explanation of how the Excel spreadsheet works. If you have any questions, definitely feel free to send me a message. I'll be more than happy to help you out with this, and definitely let me know if you found any errors. I'll go ahead and show you some of the hidden sheets with some of the math in here, but definitely use these at your own risk. So I've hidden 3 sheets in here. There's one that are chart labels. I'll show you this. This just shows the actual labels that I'm using in the chart. Um, you can delete some of these and it won't exactly break the chart, but it will break some of the labels there. But really where the magic of this happens, or the calculation, I should say, is acceleration. And I have a acceleration calculator and a weekly acceleration calculator. Now, in the legacy version of this sheet, I use a pivot table to calculate all of these. If you're using the Microsoft 365 version, this has the exact same columns, except it uses the filter function in Excel, which is nice because you don't have to click refresh data at all. And then these A cell and D cell formulas, these calculate the appropriate actual A cell and D cell value. I'm trying to expand this, but it won't let me right now. These calculate the appropriate A cell and D cell value in Excel for the spreadsheet. And this is where acceleration is calculated. This is kind of a mirror of that data sheet right here. So it just takes the data that you've entered in the data sheet, and then we're projecting ahead. Now, when we calculate acceleration, what really is acceleration? Acceleration is linear regression. It's drawing a trend line using the least squares calculation method onto a logarithmic sheet, a log 10 on the y-axis. That's what acceleration is mathematically. And calculating linear regression by hand is very, very cumbersome. It's very tiring, and I'll be honest, I haven't done that in 20 years when I took grad stats. But doing it in Excel or any computer software is trivially easy. You just use the trend function, and that is what this formula does. Now, I've got a few other things in here. I have an if-then function, but I'm using the trend. I'm using indirect so that it will find the x values or the y values that correspond with these two x values. This isn't all that complicated of a formula, but really what you want to know is we're using the trend function here. And then that's y1 and y2 for your graph. Y3, this is a projection. So the spreadsheet will project ahead, and I think I've set this to 14 days or 2 weeks' time. It will project the acceleration line, the bounce envelopes, however far you want it to project ahead. So we'll go ahead and change this to, I have it set to plus 14, but we'll just change it to plus 7. And then yep, it just shorted it by half. Now, the way projection works in the in a logarithmic chart, you can't actually use linear regression because without getting into the math, because it is multiplicative instead of additive, you're actually going to be using an exponential line. Or I can't remember the name of the line at the moment, but this is the correct formula to calculate the projection line. And you can see over here, it is a straight. It shows off as a linear line on the logarithmic chart. And then I have the standard error. Now, I've seen a lot of other spreadsheets and a lot of other software. I think Precision X, and then there's an iPad app out there whose name I can't remember. They all calculate your bounce envelopes using 95% confidence intervals. And I can see the logic behind that. And I'm not going to go into the statistical reasoning or what a 95% confidence interval is. The short version is if you calculate 95% confidence interval, then you're going to create an upper and lower bounce envelope that will have 95% of the values or the expected values above or below that regression line. But when you're calculating linear regression, you have a moving average. So what I do is I calculate my bounce envelopes using standard error, the standard error of the regression line, which again, I'm not going to go into what the math is, but this is something that when you do regression analysis, which is something that I learned in grad stats. Short version, I wanted to be a psychology researcher. I changed my mind, went into behavior analysis. So I don't have a PhD or anything, but I do have a fair amount of statistical training and understanding. The short version is mathematically standard error, at least in my non expert opinion, I think is more appropriate for calculating your bounce envelopes. And luckily, Excel has a function built in for it. It is STAX or standard error YX, which is the function that Excel uses. So we don't have to do any complex math in here. We just type in STAX. Again, I'm using indirect formulas and match to select these data. That way you don't have to manually select any data here. Again, this is a one-size-fits-all thing. And then I have these two multiplier columns. You'll notice they're exactly the same. In an older version, I was creating one bounce envelope that would be above the line, one bounce envelope that would be below the line. And it was a lot more complex. Now I just generate a ratio. That's what this formula does. I basically log transform. So you can see log 10 here. That's the log transformation of the standard error. So I just log transform that standard error to create a ratio, and then your y1 and y2 values on the graph are multiplied by, in this instance, 8.1, because I messed with the data and I made the bounce or the acceleration just gigantic. But here on acceleration line 2 for the decel value, that makes a lot more sense. And you'll notice there's a typo. So for some reason, when I was building this, I typed acel as ACCEL, and then here it was decel, which is what it's supposed to be. It's supposed to be decel with one C and acel with one C. I messed up, and a lot of the formulas require the acel and decel to actually say exactly that, and I'm not going to go back and change all of those formulas, so we will just live with the typo. But over here, this is the y upper, and then the y1 upper, the y2 upper. So those are your bounce envelopes. And then you project ahead, the y2 lower, and the y1 lower, y2 lower, y3 lower. This is a really simple formula that just determines if the data are accelerating or decelerating. If they're increasing, it's an X. If they're decreasing, then you get a divide. This is how the actual acceleration value is calculated. So the way you calculate acceleration, I put a little blurb right here, but the short version is the way you calculate acceleration is you basically calculate the difference or divide the difference between, or not the difference, the dividend technically. You basically take two acceleration values or 2 points on the acceleration line that are separated by 7 days or 7x values, and you divide the larger one by the lower one. And that gives you the acceleration. Bounce is calculated as the difference or the ratio between, or actually it's the dividend between the upper and lower bounce envelopes, and then this is the count of the number of days. All of this data gets combined in this little cell right here, and this is actually the label for your acceleration. The last thing that I'm going to show is, and I should have done this in the earlier part of the video, but you can select the multiplier. The multiplier is basically how big your bounce envelope should be. So I just changed that to 1, going back to the daily count per minute. We'll zoom in a little bit here. I changed the multiplier of the bounce envelopes. And again, you wouldn't actually calculate acceleration with data like this. This would be one acceleration, and then this would be another acceleration. So let's actually do that. So this is 0.13 or 12. So let's start our ACIL data at 0.12. And since the data over here hasn't changed, this will automatically update. And yes, now it is nice and narrow. This is practically linear data. And the acceleration, so the acceleration is 1.14 over 8 days. Not particularly interesting acceleration. Let's go ahead and change the multiplier to 2. What the multiplier is basically the multiplier tells Excel how much to multiply the y value by the standard error. You would call that your k if you want to know the actual term for that. But going back here, even with a 2, it's still really, really tight. But let's do the decel value here. That's 1 right here. And oh, that's the weekly data. I want to change this to the 1, and then we'll go back to, there you go. It got a lot more narrower. Generally speaking, you're going to want to keep it to 2, the multiplier to 2. You could go as high as 3. 3 standard errors should account for 99.9 or 99.7, I think, % of the data over here. And, in this instance, I actually probably would keep it at 3 just because the bounce envelope is so narrow and so tight. Over here, we set, in decel, we set it to 2, and you actually have one outlier right here. But regardless, the data are still in place. So I think that kind of makes sense. And I think that's pretty much it. Again, if you have any questions or concerns, definitely feel free to send me a direct message. I'd be more than happy to help. I don't claim to be an expert in precision teaching or in Excel or statistics, but I do have, a moderate amount of information on that. And I just wanted to share this, disseminate this. Hopefully this will be something that will be easier for people. And one of these days, I think I'm going to try to make some other videos on some more advanced data analysis methods that we can use in behavior analysis. So stay tuned for that.